Um, there's something called .com bubbles. I don't know any of you if I don't know if any of you heard of the .com bubble. Have any one of you heard about it? .com bubble. Okay, .com bubble is is an occurrence, something that happened, I think, 1997 to 2000, when internet was booming. Everybody, investors, our retired parents, everybody in the US invested all of their money because internet was hyping. Either the company is making good things, is not making good things, everybody carry his money from inside that internet. Like they invested a lot of money just because of hype, not because they did a due diligence that it does it require them to put their money inside that company, rather because of hype. That's the scenario that happened. And then suddenly one day everything goes down. Everybody, a huge amount of money was lost by people. What this thing is showing that if you go for robotics just because you see robots on YouTube or you see somebody do robots and you feel like, yeah, I should go and do it's going to come with a cost of energy, time, and money. Because when you're starting, sometimes you have to sacrifice buying clothes, sacrifice buying new watches, sacrifice um, even giving your guests money, like just to buy data, get components, sometimes premium software so that you can be able to practice that or not. So if you do not do the do due diligence and you just embark yourself onto this journey, it's going to be that like that combo. You invested a lot of time, money, and energy, then suddenly you give up, you quit, or maybe it will not pay off because there is no, you did not do like a realistic research of what's going on before you enter. So that's that. What actually is robotics? According to IEEE RAS, which is uh, the most largest and professional body that incorporated professionals from the industries and the academia in robotics. Robotics is a science and technology of the design, manufacture, and application of robots. And we have a broader definition here that says it is an interdisciplinary branch of engineering and science that includes mechanical engineering, electrical engineering, computer science, or others aimed at the design, construction, operation, and use of robots. Um, that's actually something. When you heard about design, development, construction, operation, and use of robot, sorry. Honestly speaking, in robotics, if you really want to understand how a robot works, first and foremost, you have to understand the ABCD behind the robotics. What are those ABCDs? Is the mathematics. When you understand those mathematics intricately, it will give you idea or it will open your eye on even how to coach the robot. How should it behave? Without that mathematics, I think you're going to suffer. A lot of things is going to happen. So for you to design, there will be a mathematics because I mean, it's not only robotics, mechatronics, civil engineering, electrical engineering, whatever we are doing, we're seeing it or we're weighing it in terms of numbers. When an obstacle avoid detecting sensor detected something, what is actually seeing is seeing a voltage. It's not seeing that very thing in front of it, but rather a voltage. When you're on top of, let's say, block C, um, upstairs, engineering block, what that slab is witnessing is a lot in a Newton. It's not seeing you as a person, no, it's seeing the lot. So whatever we're going to do, we do in numbers. Likewise, the same thing robots. Robots, you have to understand the mathematics behind it. So we cannot just go around into code, just like how some data scientists, data scientists too are doing statistics, like website designers or app developers are doing. No, you can't do that. You must do the mathematics first. When you understand the mathematics, then you can be able to do the code. And after the coding, you visualize what's happening inside a simulator to see if there are some unwanted behavior. You adjust your parameters before everything will be deployed on a physical robot to avoid wastage, like to avoid all these hardware mistakes. So what robotics is? Robotics is the discipline of designing system that senses the real world through the use of sensors, right? Make decisions using logic, algorithm, or AI. Although nowadays most of the robots are intelligent, that means they use artificial intelligence. But it's not that all the robots are using artificial intelligence. Not all of them are using artificial intelligence. Not all of them AI is being embodied. I mean, AI is being put into them. Some of them are just using some coordinates and change in time or something. Because the thing is that if you go to a company that are using arm robots back then, I don't know if there are those robots still existing, but when something is passing on a conveyor belt and you see the arm robot turning to pick or grip that very thing, it's using timing to do that. But nowadays you can see that what if there are some kind of slip or something on the conveyor belt? That is why a camera is being put that you can be able to detect if the person has even reached the position before it grips. That's it. Then act physically, which is interact with the environment through hardware. Most of it actuator. When it senses, let's say, an autonomous vehicle working on a road and it senses that there is a car in front of it or accident, then it put brakes. That putting the brake is acting physically with using the actuators. So what makes up the robot? The structure, the actuators, sensors, control system, power source, and effectors. Structure is just the body because even the classification of robot is classified, it can be classified based on structure. We have the fixed, we have the mobile. The fixed robot that include the manipulators, that's arm robot. And then for the mobile robot, we have that looks like humans or bio robotics. We have those that look like flying machines, which is aerial robotics. We have those that can go underwater, are called underwater robotics. We have those that can walk, like all these quadruple, which is on legged robotics, and we have those that have wheel, like the legs of autonomous vehicles, which are called mobile wheeled robotics. Sorry. So there are many classifications, and then another thing that is part of the robot is the actuator to combat energy into motion. Which kind of energy? Of course, electrical energy. Because whatever it is being sent from the sensor, it is being sent in form of electrical signals. It is at the actuator that there will be is it decoder that will decode that signals into a physical action. We have the control system, which now our normal we see that microcontrollers is what is controlling what a motor robot should do or what it shouldn't. And then we have the power source. Of course, it needs a source of power before it can operate. So that's also part of the robot. And then we have the end effector. That end effector, in case of mobile robots, it's called the hand. Because whatever that is being sent, the actuators, the everything, like an action has to be taken place. And that action is being taken by the end effector, which is the hand. If you look at what is it called? If you look at aerial robotics that are used for rescue mission or firefighting, you see that when they fly, they are being connected to a pipe from the tanker at the bottom. And he wanted to spray to quench a fire, let's say at a 10-story building, maybe let's say level 7. So it will fly to that very level, that story building, and then quench the fire using the what? The pump. So that pump is the end effector there. And we have a lot of branches of robotics, like a lot. And this is classified based on so many criteria. Um, please, if you can hear me, just give me a thumb so that I should not be speaking with myself. A thumb, please. Alright. So, classification of robotics can be classified based on their usage. It can be classified based on their structure, I think. Then based on what again? Okay, let's go by the classification based on their usage. We have service robotics, we have industrial robotics, we have medical robotics, we have agricultural robotics, we have defense robotics, those ones that are used in military. We have sorry, we have there are lots of them, thousands of them. And based on their structure too can be classified as humanoids, biorobotics, uh, aerial robotics, underwater robotics, and much more. So now, what are the fields that makes up robotics fields? It's quite actually vast. It's very vast. So according to this list, we have mechanical engineering. Yes, of course, because there is emotion. When there is emotion, mechanical must be involved. We have electrical electronics engineering, mechatronics engineering, control engineering, embedded systems. Like some of them in the list are actually sub. I mean, let me say they are actually a specialization of the others. If you look at this control engineering, there is control in mechanical, there is control in electrical, right? So it's actually part of electrical. If you look at embedded system, it's part of electrical electronics. If you look at artificial intelligence and software engineering, actually part of computer science. If you look see mathematics, physics, optimization and pressure research, computer vision is also part of computer science and stuff like that. That is to say that um for you to be a good robotics engineer, you have to have awareness, or let me say background knowledge of all those better and better collaboration between teams. Because if you cannot cook with what somebody is saying in your team, then I think the project you are going to work on or you are working on is going to be somehow bad. So sometimes you have to understand the perception of how somebody did something in a team so that you can do the one you are doing. And you hardly see one person do it. Yeah, you can do it, sure, but in industry, due to speed, you hardly see a single person doing building a robot. You see like 8 different people. It's AI engineer, Slam, partial AI engineer, perception engineer. You see navigation engineer. You see the one that would design the robot itself. You see different types of engineers. Everybody taking a part so that they can build it in faster. So that's like it's huge. It's huge, honestly speaking. As you can see from the list, different, I mean, uh, vast number of things is what makes up a robot. So now comes the big issue. A person who wanted to be a robotics engineer, and you see him so much immersed into embedded system or into PCB or into website design or into any other things that's there. So there are a number of fields that actually looks like robotics, but they are not actually robotics. The first one is mechatronics. So as you can see here, they said mechatronics is a broader field that combines mechanical engineering, electronics, computer science, and control engineering to create intelligent systems. That is to say, if we are to take, for example, common um, this door that we have, maybe I don't know, in some federal government agencies, that when you come, it has to scan your face if you are allowed I mean, if you're authorized to enter that very building, then it will open the door for you. That is a mechatronic system. A pump that will detect that, I mean, a sensor that will detect, a system that will detect a certain level of water in a tank that is low, and then switch on the pump to pump the water. And when it reaches a certain level or it is full, it will switch it off. That's also a mechatronics system because what it encompasses electrical, encompasses sensors, actuators, and then the algorithm there is computer science. So that's mechatronics for you. But then robotics is a subset of mechatronics, focused specifically on design and programming robots to perform tasks autonomously. So unless even if you're a mechatronics engineer, you specialize on only design and programming robots, your career track you say that it's not robotics. If you are doing another things, even though you are a mechatronics engineering student, that is not specifically targeted to robots, and your career track is not robotics. That is why robotics is a subset of that because robotics too, it has computer science aspect, it has embedded science as embedded systems aspect, it has mechanical engineering aspect, it has control engineering aspect, and electrical. That means it's a subset of that. And you are only going to be in the trajectory of robotics only when you are specifically dealing with robots. And that's what I specifically do in ATBU. Like if you ask me within my colleagues, anything that is not robotics, you hardly see me having interest in it. Back then I used to do it, but I begin to see that I realized that I used to burn out to things that is not necessarily in my career aspiration. Therefore, I dump everything and just focus on robotics. Even the robotics at the moment is giving me auto to. I swear to God, it's so easy. Almost the, if you enter the robotics too, you see aerial robotics, you have to understand all these aerodynamic stuff, whatever, the way the way and manner that it can be able to avoid hitting a pole or a tree when that is flying. That means at least when it is autonomous, you're not controlling it. If you go for underwater robotics, you have to go and borrow marine engineering stuff. That is is huge. I mean, even the robotics cannot do everything. You have to choose. And it's they are like I've mentioned, we have I mean a huge number of vast number of things for you to choose. You master one. At least if you wanted to master like three, you start with one. When you reach a certain level of it, you choose another one. So when starting to go for robotics, don't just carry everything. You are going to survive. Just going to randomly just be malangering without having a direction. That is why it's very good to have a mentor when you're going for robotics because I really experience it. The kind of stress, depression I have because I don't have anybody that will guide me how to do this thing, what to do, and when to do it. So that's for the differences between mechatronics and robotics. And then for the AI, artificial intelligence is a branch of computer science focused on creating systems that can learn from data, recognize patterns, and make decisions usually within a software. So you see, if you program a model that can be able to predict prices of a house, that's an AI based on data. Yeah, it can the data might be labeled, might not be labeled. That's it can be supervised or not supervised. So that's an AI. But then there is something recently, at least for me, that is called embodied AI or physical AI, whereby AI is used or deployed to be trained on physical quantities. I mean, physical scenarios. Maybe you can train a robot. Let's say temperature, all those stuff like that, whatever. All these physical scenarios. Understand? So And this robotics is an engineering discipline that designs, builds, and programs physical machines to sense, decide, decide, and act in the real world. Essentially, AI enables smart decision, perception, planning, while robot enable physical action. A robot may use AI, but AI alone is not a robot. What is a second is that if you can see, there's something called simultaneous localization and mapping. That simultaneous localization and mapping is ability for the robot to simultaneously know its environment and then map its way towards its target. Let's say it's not the environment, that's localization. Where it is this a wall or not or not a wall? Like the entire map of the environment, right? And then find its way, how to navigate. Maybe let's say the robot is at ATBU gate and you wanted to deliver something to somebody at Sambisa. Ability for the robot to know that it is at the ATB gate, that's localization. And then mapping its way, like path planning to Sambisa, that's the mapping. To know that this is where I'm supposed to follow to get to Sambisa. So that one is not AI, it's mathematics. But then when the robot is going and it see a robot or a engineer or a student trying to crossroad and it understand that it's a human being, that's an AI, right? That's literally computer vision to detect an obstacle and then pause for a while to let the person cross before you go. So it's not that almost at this moment, most of them are having some kind of certain degree, certain level of AI because the things are becoming much more complex and complex. It requires AI, unless maybe something like arm robots. Even the arm robots are Gemini now. They are trying to make it very, very intelligent in the sense that you can be able to type, give it a command to a prompt, just like you can do to ChatGPT. You can tell it, let's say, to cook something for you, and it can be able to recognize this is this thing using object detection. So that's AI for you. If you look at autonomous vehicles too, you get to understand that it's almost fully, no, it's not fully autonomy, it's high autonomy. It's high autonomy, like it has AI in it. Another discrepancies, I mean, another issue we have is automation, but this robotics. Automation is all about something that is be repetitive. That's not only in hardware, but it is in AI. I mean, in software. When you message a company through WhatsApp and they have a WhatsApp number, they will tell you hi. Just if you look at Ziggy, for example, in order to get to the customer care agent, that reply that you used to do to you, that's an automation, repetitive task. And if you look at conveyor belt too, it's repetitive tasks. If you look at our what is it called? Traffic light, yes. Our traffic light are not actually smart. They are just automated. That at a certain seconds, after a certain seconds, it will allow other lanes to go. And after certain seconds, allow other lanes to go. So that's virtually what automation is all about. So um, actually is an, a robotics is under automation, but not all automated systems, automation systems are robotics uh, systems. If you look at the example I gave, like the automated agent on WhatsApp, that you can send a company message and that thing will reply to you. It's not a robotics. If you look at the traffic light, it's not a robotics. If you look at the computer, it's not robotics. Um, there are some doors too that are automated in some of the plazas. I don't know if you could see if any of you have ever seen it. That after a certain seconds it will open and close. After a certain seconds it will open and close. It's not that it's detecting if the person is present there or is not present. No, with just a timer to open and close. That's automation. Now, since a robot can do a repetitive task, it's still an automation system, but not all automation systems are actually a robotic system. Now, the one that we usually have issue the most, or we think it's much more closer to robotics, actually embedded systems. When I was doing my internship at Nascomsoft, I actually, I think after we spent I think 2 to 3 months getting the foundation things that we're supposed to know, Uncle Nas all uh, decided to give us a niche. I think there were three niche: robotics, IoT, and then control. Those of us in robotics were not actually that much. So it was there, Litima was there, who else? I think some other guys from EE and mechanical. Well, there's ABT, another colleague of mine, 500 level mechanical. Most of them go, some of them like old money went for IoT. The other guys went for control. So that is to say that even in embedded system, you can choose to align yourself to embedded robotics embedded systems uh, projects. You can start working on all these motor robots and stuff like that that are aligned to robotics because from there you can be able to build up and have foundational understanding of how robots work. You understand? But if you carry the whole embedded system itself, you will actually be lost, honestly speaking. That one is vast. You see HAI, you see all this ability to control something using Bluetooth or Wi-Fi. That's not actually robotics. When you are too immersed in that thing, you lose, you drift, you drift from your trajectory as someone that wanted to be a robotics. Actually, you look like your career aspiration, especially if you are finding things very, very fun. So what you're saying here is that, according to the document, embedded systems are low-level computing systems designed to run specific tasks on hardware with strict timing, memory, power constraints. Right. Robotics use embedded system to control sensors, motors, and communication. But robotics also involve perception, decision, and physical interaction. So you see the differences I was talking about. That one normally runs on low-level computing systems. Like even this thumbprint that I used to do maybe during when we're trying to enroll in a BVN, we're trying to enroll uh, NUC, what is it called, NYC, mobilization, all that kind of stuff. That this thing, that device that you do, that you're using the thumbprint, it's all this embedded system. The POS that are using embedded system, some of the devices they are using, biomedical devices they are using in hospital, embedded systems. Um, an AC that can readjust air conditioner, it will adjust due to the condition, I mean the temperature of the room. Embedded system, it has a sensor when it senses that the temperature rising a little, then it on the AC. And when it discovered that the environment is very cold, it on the AC, but warm one, not cold one. So all these things embedded system when they have a controller that is controlling that behavior. So I think okay, this is not for us actually. Giveaway tax, that's something else. So this is what I'm talking about, I think. Mobile robotics, underwater robotics. This is some of the projects that my boss have worked on it. Actually, I think after the session we will see for those that like to want actually to go through over through the slides, we will send it underwater robotics competitive, area robotics bio inspired, field industrial multi robot manipulation. So that's how it is. Sorry. Um, the thing is that, like I've said earlier, the combo, don't go to robotics because you've seen somebody doing cool things in robotics. I mean, very, very interesting thing in robotics. Go to robotics because you understand how difficult it is, and you are going to endure that difficulty to achieve greatness. Like that's just it. And don't go because you've seen it on YouTube, like blah 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 blah, yada yada yada. No, do your research, talk to somebody, find out if really robotics is what you really wanted to do, because it requires three things at least three things. Money, you're going to spend money. And I'm not saying even when you get hardware, so even your data alone, because we don't have access to robotics education offline. Let's say in Bauchi here or in our respective states, majority of us. But you can have some of the access online. For you to access something online, that means you're going to spend a data, right? Only data alone. If you are a low income earner like me, you have to sacrifice buying new clothes. You have to sacrifice a lot of things that make you comfort. So you have to make discomfort your comfort first in the first place. I mean, it's not going to be easy for you, honestly speaking. Especially if the community are very, very serious. Like they are committed to make things happen. Because for a robotics initiative, being it education or building project or company is not going to be an easy task for them. If you really want to do it, you have to get serious people. And don't deceive yourself. You must have to be devoted to that. I mean, you have to be very committed to it. Like, and when you're understanding it, you have to understand the mathematics intricately. You're not understanding it like from the step the IDX is being done to this step to this step to this step. No, you have to visualize the behavior in your eye. When they say that using um, using what is it called, clockwise counterclockwise convention, not a zero convention, you have to see the behavior. When a robot turn right, is that a negative angle, positive angle? And you have to tell the differences between wall frame, people that with you and all this kind of stuff. It's not easy. You cannot just read the way they teach mathematics or control in ATBU and then pass. No, you have to understand it. Like you have to see the behavior in your eyes. They are teaching you how to that you see it in your brain. That's the only way to survive. You cannot survive there by just shying the steps, just like normal to pass exam. No, you have to understand everything. So don't do it because you see somebody doing it. Don't do it because you really understand what is the reality of it and do it. That's about all this notes of the company. So that you will not end up regretting wasting your time, energy, and, and money into it. So, um, robotics to make more or create more. Honestly speaking, you create more than like important industrial revolution and also do jobs. And mind you, there's when you are so
Um, while we wait for okay, sorry, he's back. So, or while we wait for him to come back, please start getting your questions ready because immediately after this we are moving to questions concerning the topic he just talked about.
I think he's out of the meeting. If anybody has any question, just write it down. Maybe if he comes back, Paul will take it. So I think we should proceed.
All right. Um. Okay. So now we know what robotics is, and the next session we are going to is why IEEE. So we understand robotics, and so we want to look for a global structure that exists that brings people like us together to push this field forward. And that's where our next speaker comes in. Our next speaker is Ibube Anene. He's the interim chair of IEEE ATBU chapter, and he's going to be taking this session. Please, a round of applause as we bring him on.
Thank you. I'm not going to take time. This is quite late. I was actually the one that told Usman that this timing is very weird for me. So I don't know if you can hear me very well properly. No noise, no frequency sounds or whatever. Am I crystal clear?
Yes,
Okay.
you are.
Okay. Okay. So without further ado, I wanted to do is share a slide. Let me just do that. Well, in the meanwhile, I'd like to once again welcome. I'm a very informal person, so please don't mind the way I introduce you or welcome you. I'd like to welcome the vice chair, Ismail. I can see him here. Who else? Farouk was here. Farouk was the past president for Nine, not anymore. And I can also see Chizaran from Kutu. You're welcome. We are grateful that you graced our program. So yes, we haven't actually um, been giving the we haven't gotten approval yet for our RAS chapter. It's still in the works. We've submitted a petition. We are waiting for approval. We've had one or two of them already approved. So we are still waiting. But in the meanwhile, we just wanted to have a brief, just a brief, um, let me say, intro session to what RAS is all about. So I'm sharing my screen. I don't know. Yeah, I can see my screen. So if you see June 4th, June 2025, I don't know. You guys cannot see my screen, right? Yeah, I think so. So this was our intro session last year for when we started our student branch. And funny enough, we're having something similar today, 4th June 2026. This is like exactly 1 year that we had this particular intro session to the student branch and what it's all about. So that's that's a nice thing. And first to I know a lot of us here are already IEEE members or know about IEEE. If you don't, I'll just quickly briefly go through this so that you can have a little bit of idea of what IEEE is all about. Yeah. So I've graduated right now, so This is I didn't edit this slide. This is exactly as it was last time. So yeah, that's my name. For my two guys, thank you for coming. My name is Chukwudi Anene. I'm the chair, at least for now, for the Akupuli student branch in ATBU. I'm a graduate of electrical electronics engineering. Yeah, so Akupuli, I guess you can just briefly go through this. 1884, some American engineers founded AIEE, and over the years it has evolved into IEEE, Institute of Electrical and Electronics Engineers. And IEEE is synonymous with technology and innovation. Practically everything technology in this world has some roots to IEEE, and it's also the largest organization in the world. I think this year it got to 500,000. The student branches um, basically geographic units of IEEE, right, where students in a specific university gather together, like-minded, to learn, grow, and reach opportunities. And it's also a way of getting insights to experts, to mentors, and also increase your leadership skills through voluntary roles and other things, right? So building your leadership. IEEE has a few extras. So let's copy some of them. The society memberships. So for instance, we are actually in the Robotics and Automation Society meeting. So class is one of the societies within IEEE. There are about 39 technical societies. We also have special interests, right? Special interests, yes. So, for instance, women in engineers, and it's called an affinity group. It's under IEEE. And we have technical communities. Technical communities are basically kind of a um, exchange, should I say exchange or interaction between different societies. So we have is it or councils and that councils. I'm mistaking that for councils. Councils is actually yeah. So they have different councils. Different councils have different societies as members in the council, and something like that. Yeah. So this is the special interest groups, WIE, young professionals, sites, and technical societies. Like I said, we have 89 technical societies. Class is one of them. And so in our student branch, we have the IES chapter. IES is Industry Applications Society. It's also one of the technical societies of IEEE. And then we have others. So we are trying to get as many as we can possibly set up in ATBU. So for instance, we are also working to set up an EMBS, Engineering, Medicine and Biology Society, and IMS, Instrumentation Measurement Society. So we have all of that in the working. Then I think the biggest thing here is volunteering. I'm a volunteer with IEEE, as there's so many other people here. And these positions will help you as a student, right, to put you in places where you probably wouldn't have that access to if you are not volunteering. I think I'll give some examples after. So there are different ways of volunteering. Um, There are so many. This is just a few. Yeah. So you can volunteer um, in outreaches, going out to communities, and then pushing IEEE and technology, and volunteer in your students branch, in our case, ATBU student branch. And then you can also volunteer in the section. The section is we have the Nigeria section and different other sections, right? Then we have regions. Regions are um, the wider geographical units of IEEE. So, for instance, we have the region 8, and it consists of Africa, Middle Africa, Europe, and Asia. Yes. Um, so, yeah, if you are studying a, um, a course in any of these fields, you are eligible to be an IEEE member. Um, so, um, of course, I can't quickly go through all the benefits of IEEE, but I'll just read a few, right? So you can join as student member, graduate member, professional member. So, for instance, if you are a master student, you can decide to join as a graduate member. If you are an undergrad, you should join as a student member. This membership is not free, right? So you pay a very small amount um, compared to what you gain. You pay a small amount for membership. So for student members, I think it's $14. Um, yeah. So yes, thank you. I'm an anime fan. That's why I have that over there. So yeah, just to quickly give examples of what I've gained as an OGP member. So I've been a member for 2 years officially, but I've known IEEE for much more. Um, and in just 2 years, I have gained lots. I have met very awesome people. IEEE, let me just let you know that IEEE has a lot of wonderful people. There are a lot of people that you meet in IEEE that will shock you to your bones. So I have met a lot. Aside that, I have been exposed to um, leadership. Like I am, if you know me, I am a very, how will I put it? I'm very reserved, right? But people has pushed me out there. So that's something you get to gain. I have gained in, I've volunteered in conferences. Um, I have met wonderful people. I have also had the opportunity of traveling, um, thanks to IEEE. Traveled to Ghana last year for the Students and Young Professionals Congress. Is it Congress? Yes, Congress in Ghana last year. Um, I have gained monetary funds from IEEE. Last year, I won a fellowship that came with a scholarship grant, right? Um, I've also, participated in technical contests, right? So, for instance, this year I was well, opportuned to have one of my projects entered into the international student contest of IMS. IMS is Instrumentation and Measurement Society. And so I was supposed to actually go and contest that project in France last week. Then, of course, due to some visa issues, I couldn't go. But all the same, that was and it was fully funded, right? So these are these are benefits and opportunities you get in IEEE. Um, there is a lot more, but I guess this is something you should uh, think on. So don't allow yourself to stay limited. We know what Nigeria is now. Um, we shouldn't limit ourselves to what we are being offered in our schools and the level of exposure we have. So IEEE will help you expose yourself um, to those things that will matter in your career, right? Especially technical, and you get to have technical exposure. I've had a lot of technical exposure in my 2 years as an IEEE member. So yes, I think that's me going to end. And this is my short presentation. So is there any question that we quickly move on? So I guess there's no question. My various points are clear. How many people here are IEEE members? Can you raise up your hand? If you are not an IEEE member, not an IEEE member, I just want to those that aren't. Oh, that's nice. I guess everybody here is an IEEE member. Oh, Stephen is not an IEEE member. Stephen, and so I will encourage you to research IEEE. Just go ahead, look at IEEE and what IEEE offers. And I promise you, you will not, if you take things very serious with IEEE, you will not regret joining IEEE. So I think I'm done here. And over to you.
Thank you so much, Ebube, and I hope we have learned a lot. So today we have learned about robotics, we have learned about IEEE, and now we're going into why RAS specifically. And we have someone special in our midst. Our final speaker is invested in building systems that expand access to engineering and digital technologies in underserved communities. Her work sits at the intersection of robotics, embedded systems, and sustainable energy, with a growing focus on democratizing access to robotic education across Africa. As past chair of the IEEE Futo Student Branch, she led initiatives that secured over $2,300 in international funding and delivered hands-on STEM outreach to secondary schools. Her current research centers on human-robot interaction, specifically designing robotic systems to be accessible not just in well-resourced lab, but everywhere. And she's driven by one goal, to build scalable systems that enable young people, regardless of background, to use technology to solve problems within their own community. And it is my pleasure to welcome Chizaram Pere Osuji. I hope I pronounced it well. And you're welcome.
All right. Good evening, everyone. Please, can you confirm if you can hear me?
Yes, we can.
Okay. Um. Okay. As I've been introduced already, thank you so much for the opportunity to speak with you guys. I appreciate. I was actually informed about this a bit late, so I'm going to apologize in advance because my slides are kind of disorganized and in different websites. So I'll share my screen shortly. So basically, that's my LinkedIn bio. Actually, if you guys had asked me, I'd have sent something simple. LinkedIn makes someone look so professional. Please, I'm a very simple person. So basically, I am the past chair for IEEE Futo SB. I just graduated from mechatronics engineering in Federal University of Technology, Owerri. So I joined IEEE a bit late because that's one of my regrets about IEEE. There was no one in my school to push me in it, even though we had active senior members in IEEE from my school, like the current Nigerian section chair. She's a lecturer, be a professor in my school. So basically, IEEE wasn't active then in my time. So I joined like in 2024 when I was already my theory level, I think second semester, right? And it was not a bit late, but a bit late because nobody was there to push me, to direct me on how things are in IGP. So I had to figure out a lot of things by myself, right? So back then, IGP Futures, we used to host events in different societies without having the society formed officially in the student branch. So that's one thing I noticed. So that's the first thing I did when I came into power, along with our chapter advisor. We were able to form IEEE RAS. It was the first student branch chapter that was formed in 2024. And from there, we began to push. So I don't really want to share about IEEE RAS without bringing it from the end of my own journey, right? So basically, after we formed RAS around, I think, July 2024, we applied for startup grant and we were able to host, like, I think, 2 workshops that year. We also invited speakers as robotics engineers from, I think I reached out to them on LinkedIn to come and speak to our student community. And so I think one from UK and the other one from India. So they just came to buttress on how robotics is advancing the fields of healthcare and automation, and it was quite a wonderful time. We just did it like you guys are doing, just to onboard students and bring in students, and so they can get engaged in what IEEE RAS is all about, because there are a lot of societies in IEEE, right? So how do you get students engaged in the one that is quite domicile around this area? So that's like what we did. So quickly, I'm going to just share my screen. Please hold on. Okay. Come on. I don't even know which website. Okay, so I'm just going to give a very brief overview of what IEEE RAS is. So it's one of the technical societies in IEEE, but this one is like the main one, focused on advancing robotics and automation, as you can see, through research, education, standards, competitions, conferences, and development, right? So why should students join IEEE RAS? One thing about RAS, the society, and what it has brought about in our school, right? Because before I went, I had to establish RAS so that students will still become engaged. Like they work on projects and competitions, and we used to host like workshops to get students involved in robotic stuff. So like it's brought about exposure to developments happening globally. We start with where we are. We start with where we are, right? So we can't just become what they are yet. So you just have to start from where you are. So that's one of the things that help push people's interest in robotics, or rather, is still pushing people's interest in robotics. It's not from what we learn in classrooms, right? Because classrooms are a little exposure to what the real world in robotics is all about, right? And it came from attending events, workshops, and engaging with activities with RAS community all over the world. Now, one thing I love about Robotics and Automation Society is the fact that if you check the website, I think in the SAC website, whereby they have SAC is Student Activities Committee. That's the secret to getting more students to participate in IEEE in an IEEE society. You give them a seat in the table so that they can have a say in how the organization is run, right? So like a lot of student members, mostly graduate student members anyway, but we have students that are on the SAC committee, apart from the global SAC team, that there's a global SAC team whereby students come together and get RAS visible for students, right? So at the end of the day, why people join RAS is not just because of the exposure it gives, it's because of that opportunity to have a say in how the society runs, right? So currently, the SSR, we have a Slack group chat whereby we kind of drop initiatives or ideas on how to push RAS for the student body, right? Because last year, I noticed that RAS Day event in 2024, rather, there was just one grant, there was an award to hosting an event in RAS. So once a chapter, you have to have a chapter in your school to participate in that event. Once the chapter hosts an event, you apply so that you can participate in the awards that will be tied to the society, right? So at the end of the day, last year they brought about like three more initiatives to get students engaged in RAS. I think that was, they brought about photo contest, logo contest, and then video contest. Now, the logo contest was about designing RAS Day logo for 2027, or rather 2026. Like the person that will win the contest, they will send the person, I think, RAS kits and all. So I think a student from FUTA won that logo contest, and then the video contest, it is not a student from Nigeria that won it, but the photo contest, we participated in it. That's my student branch. We actually able to get like 2 grants just to host one day event. It was actually crazy. RAS, the initiatives they usually bring out on a daily basis just to get students engaged in what the society is all about. Like there are a lot of amazing opportunities. So like this is the website for SAC. The SAC is responsible for organizing and managing events to recruit students and keep members active, right? So that's one of the goals of this SAC committee now. So that's just like one of the benefits of joining RAS. I didn't say you join RAS and become a part of the SAC team immediately. They call for joining a SAC team. I think it comes out once in a year. Last year's score came out around December. I think that's the one the guy from OAU he got. That's he's part of the conference SAC chair, co-chair. That's for RAS. Yeah, he's supposed to be in Austria, but I don't know why he didn't go for the ICRA. He's hosting. I mean, he was to host. Yesterday was Wednesday. Yeah, he was to host a workshop in ICRA, but I don't know, he couldn't make it or so. So that's one of the responsibilities of being conference SAC co-chair. He was to organize a workshop in the conference, and so that's like it helps to get you engaged in with people from all over the world. So that's like one of the benefits of joining IEEE RAS. So another benefit is these standards. Now, a lot of us may have seen this ICRA Spice competition. It came out around December, and they've already awarded the awardees. The one person won from Nigeria. ICRA is IEEE International Conference on Robotics and Automation. This is the largest robotics conference in the world. It's over 8,000 attendees. It's currently going on right now. I think they're closing tomorrow in Vienna, Austria. So, like, they bring out this competition. These are the benefits of joining RAS. That's one of the benefits, actually, these travel grants, because a lot of people are always interested in, going outside for conferences like this. So, like, the initiative is to encourage students to play an active role in existing robotic standardization efforts. And so RAS brought out, this set aside some funds so that students will participate in this ICRA. So one student from my school actually won the travel grant, but unfortunately, Nigeria happened to him. But that's by the way. So that's like this for ICRA. This for ICRA. There's also another one, I think, is IDEA. Yeah, everybody knows about this one. People are always looking forward for this one because it's the best, as far as I'm concerned, it's the best travel grant in IEEE. Whereas most travel grants in IEEE require you to go for the conference, and when you come back, they will reimburse you, right? So you have to pay everything up front, except conference fee. They just give you a code, and then you use that code to get free registration for the conference, and then that's by the way anyway. So this idea is inclusion, diversity, equity, and accessibility. So it's a travel grant that it pushes that it focuses on increasing diversity in our community, and is for eligibility is for undergraduate students interested in robotics and automation topics, underrepresented groups, women, minorities, blah blah blah. So basically, this travel grant is wonderful in that they pay everything for you. You don't have to. Okay, it's only visa you settle yourself. I think yes. So the rest they settle. So it's a fully funded trip. So it came out last year. I remember 28th February 2026 when they were about to send rejection emails. I mean, it was crazy. This idea grant, everybody's always looking forward to it because it's as I said, it's the best travel grant in IEEE as a whole. Because if you get travel grants in IEEE, you will just know that you will sweat, not just the going for the conference and all, but just the opportunity to get the travel grant is one thing, but then going for the conference is another thing, right? So like 28th February was when they shortlisted, and at the end of the day, a lot of people I got rejection letter for this one. It was crazy. I mean, the way they shortlist, they have to consider the what do they call it? The groups. Like you can't just in a situation whereby you have 10 girls and 5 guys, you have to just choose like 2 girls and then 2 guys. So not because they say underrepresented groups, women, you not think they'll select only women. So they actually divide it very well. So it's a travel grant for both guys and girls. Please don't mind these underrepresented groups. Guys are also among underrepresented groups in Nigeria. So that's another benefit. Now, another benefit is also the fact that you can actually engage in okay, I've talked about it. That's the community, right? So I saw a link that was 2024. Back then, I was like crazy. I used to search for different opportunities in ITBU RAS. Like I've gone through these websites like completely. There's nothing in this website I'm not aware of. Well, I'm almost everything, sha. So like I used to search for opportunities. So I saw an opportunity to volunteer in the IAB, that's the Industrial Activities Board, which is the standards. So I saw it in 2024 and I applied for it, but I didn't hear from them till like this year. Imagine applying for a volunteering opportunity from 2024 till now. So that was in April. They reached out to me. They were like, am I still interested in volunteering in the standards community? And I was like, why not? So I indicated interest. And from there, we've been active now. These are the standards and the approved standards in IEEE RAS at the moment. So I don't really know how to explain. Standards are they're like universal languages that allow different technologies to work with each other. I don't want to use the ontology ways that they used to explain it, but it's a very, very simple thing. It's just how are you able to make systems work effectively, and something about HRI, how to make humans and robots to work effectively without any form of breaching trust and all this kind of thing. So that's where standard comes into play. It has to do with they bring about blueprints, that's safety rules that can ensure that both a human and a robot, that's a human user and a robot, can work seamlessly. So these are like the approved standards at the moment. Like the one I'm working on, or rather the group I'm collaborating on, is this P3107, and then I think this, where's that one? Okay, it's this one. So like there are different standards in ITP. You can go to the website later, you can apply to volunteer. I think the call is always open, but they choose a time by which they can onboard volunteers, because currently this standard now, they are closed. When I mean they are closed, they're in the balloting group whereby they are voting for a particular step in the project. Let me not call it project, but in the documentation to move to another step. So they just close the group for voting. So we are just in the mailing list to know when they'll open up the standard again. That's the working group for people to participate and still collaborate on other things. So like that's like an avenue for students to come in and know more about the standards, so that perhaps in the future applying for SPRICE, it won't be an issue, because this prize is mostly for undergraduates. I lost the chance in applying for it back when I was a student, because I did not hear about it. When I heard about it last year, it was really late. I mean, I tried for case in China. I think it was case in China. I think case last year was in US. I tried, I didn't get it, right? So I wasn't engaged in standards then, and I am now. But it's kind of late for me to apply for where is it? This price zone, IROS is in US. So I didn't really stress myself thinking about it, because they made it in such a way that it's only for students. They literally said it's for undergraduates alone, unfortunately. So that way is it. They said this award is for undergraduates, and priority will be given to students that would not have attended IROS otherwise. So IROS is in US, and with the current travel ban for Nigerians, unfortunately, I really don't even know how they will go about this. Anyways, that's that. So I'll just get back to this. I think I'll summarize with this. So I think this was January. Yeah, January 2026. I follow different websites in conferences to know if they will have avenues for travel grants. I followed for ICRA, but ICRA, the only travel grants ICRA had was for those that had written papers, and I'm not yet in a state whereby I have the capacity to write a research paper for robotics conferences like this. So basically, I didn't try for that yet. So, but it's something I'm looking forward to in the future. And basically, I saw this one. I opened the website in, I think that was January, and then they opened, because RoboSoft is the international conference on soft robotics. Soft robotics has to do with fields of robotics that is reliable, that's flexible, and the materials are what's that word they used to use on my way for this conference? I don't forget. So the conference is all about soft robotics. It's just a field that is different from hard robotics. Hard robotics are made with metals and plastics, like all these materials that easy to break and bend. But soft robotics, from the word soft, is just very flexible materials, very easy to use, and deflatable materials, like they can easily maneuver through environments because of that compression inside of them. The materials that are used for these robots are very, very soft. Like, that's the word I'll use. Anyway, so yeah, I saw the travel grant. It came out in January. So the eligibility, I fell into the category for at least like 2 categories. I was in it. So I was like, okay, since they're not asking for a paper and I didn't write a paper for the conference, so let me apply. I didn't really look at this part that has to say that said, okay, you must present something at the conference. I was just interested in applying. Because one thing about IEEE RAS, you don't always see avenues like this to apply for travel grants. So I was like, why not? Let me just apply. What does it take to give a talk, right? So I saw it, that was January. And I just prepared what I wanted to submit, and I think I submitted it. Okay, I submitted it before the deadline, Sha. So basically, I think that was this February 27th. I can still remember that date like yesterday. I received the email that I've been accepted to present a research work in the paper that's with regards to these spotlight talks. And it was wonderful. When I mean it was wonderful, it was an amazing opportunity. I mean, who doesn't want to go to the conference? Was held in Japan, so I was like, okay, why not? Let's see how we'll go about the whole stuff. So that was February 27th, and then March, the period of March, I started processing visa, and by God's grace, the Japan embassy was merciful unto me, and they were able to give me visa for the conference. So I was able to go for the conference. Let me go to that presentation. Yeah, so I was selected. I was actually the only undergraduate, because even in the application, I saw something about are you a master's student or a PhD student, then others. So I just clicked on others. I then wrote just finished bachelor's degree, right? So I cannot lie because I'm looking for travel grants, right? So basically, in the conference, we had 4 people selected to speak on democratization of soft robotics for underrepresented community. Now, basically, what I do, my work is basically on just expanding access, that's improving access to robotics. I did a lot of STEM outreaches last year to engage students from pre-university, that's secondary schools, on the benefits of not joining, the benefits of helps to lower the barriers of STEM for these students. So like, it's not like a research work, but because of this conference, I had to frame it as a research work, because they didn't want to hear about the outreach directly. They wanted to see the technical work that we embedded in the program to, democratize access to soft robotics, right? So during the conference, it was crazy. I was feeling so left behind, because as the only undergraduate, although I finished my undergraduate degree, the other speakers, one was a postdoc, the other one was a PhD student, the other one was a master's student. So I think they just picked one of each degree, right? So I was to speak on a framework on improving access to soft robotics, right? And this is me, that I've not really done any work on soft robotics. It's in that conference that I really knew a lot about soft robotics. But the travel grants made me, I had to start researching, like, what framework will I use to propose this whole stuff? And it made me quite interested in this field of soft robotics. And even though other speakers, they kind of focused on the technical side of soft robotics, because some of them were already involved in soft robotics. But me, I just finished my undergraduate degree. I just did something on hard robotics as my final year project. What do I know on soft robotics? So while others frame their own presentation around the technical side of robotics, I came from my approach from the perspective of education and access. Like, how can we make robotics learning and tools available to underserved communities, right? Even like at the end of the conference, I had people that reached out to me. They were like, okay, they were interested in my talk and how to improve the access in our regions, because let's face it, I mean, in conferences like this knowledge is like, it's just for people in this room. For a Nigerian or for an early career engineer in Nigeria, most of what they share in that room, like, it's not domicile here. It's like science fiction. Like, I was like, how do you bring robotics from this region to here? Like, how can we improve access? Because we still have a long way to go in terms of pushing access to robotics in our area. So like, I really learned a lot in the conference. At some point I was overwhelmed with the new knowledge in the room. I was like, oh, we have a long way to go. We really, really have. And it's kind of stretched me in a way in terms of knowing that, you have to work on yourself too. It's not just saying people have work to do, but how are you pushing in your own area? How are you pushing in where you are, right? You cannot just want to get to the stage where they are. They have fundings. They have well-equipped laboratories. Oh God, it's like, how can we reach that stage? We start from where we are, so that at the end of the day, it's just part of what it is. We just have to get engaged with what we are, where we are, and push from there. So that's the thing. So it's expanded my perspective on what robotics can become when accessibility and inclusion, that's inclusivity for people like us, are treated as part of the innovation. So like, these are the lessons. These are just a few lessons I learned from the conference. Robotics research is, I saw a lot of robots. Like, there was one I saw on exosuits for people that have back pain. The robot helps to straighten, not really straighten, but helps with you standing up straight, because if you have back pain, you should be standing up straight. So it's like an exosuit, and it deflates. It was comprised of a compressed air, whereby someone have to press a button somewhere to help you to stand up. I mean, I saw a lot of wonderful projects in the field of healthcare and assistive systems, assistive robots, cobots, and all these different kinds of robotics research. I mean, we may not have the same resources that they do, right? But we can still contribute meaningfully from our own context, and we start from what we have and then build from there. So that's like one of the lessons I learned from the conference. And so these are just a few. I was told to attach pictures in this slide. This is just a presentation I did in a community in my school, and just last week. So I still have the slides here. So this is like, these are humanoid robots. These are hard robots. Then this is a soft robot. This is a soft robot. I think it's made of what's this? This is, I really don't know what this thing is, but this is a snake. This is a shell. But this is how a soft robot looks like. A soft humanoid robot anyway. So this paper, this was like, I engaged in different poster presentations, different plenary talks, and it was actually wonderful. This was my best poster so far, because I'm into the work of HRI. So how do we talk of soft robotics in terms of HRI, that's human to soft robotics interaction? So the work was all about bringing in novice users to engage with a soft robot, and they broke down the tasks into three designs: a object knockover, target touching, let me see if I can expand this, and then shape matching. So the novice user, this is a non-expert user, so they brought him. This is a project they worked on in Purdue University in US. So they brought a novice user and gave him this task to work on, and at the end of the day, they were able to track his heart rate, his eye, the way they work was for him from easy to hard and from hard to easy. And for most of us, if you engage in an easy task, it will be hard for you to do a harder task. But if you start with a harder task, you'll be able to blend easily with the soft task. So they were able to track his different responses, that they tracked his mental demand, physical demand, temporary demand, and effort and frustration. And it turned out that the frustration level was higher when he was moving from an easy to a hard task, which is how normally it is for most of us. So like, this is a research work. Imagine just doing something. It seems easy, but this like months. And from the professor that presented the work, this was like months and years of research, and how to now put it into a paper like this that will be accepted in a conference for presentation. So that the paper just contributes to the emerging field of HRI, but in terms of soft robotics, by demonstrating how these strategies can affect user performance and blah 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 blah. So yeah, that's the thing about soft robotics. So the conference exposed me to the field of soft robotics and how the field is advancing in different fields, subfields, right? So that's the advantage of being in RAS. I mean, I've gained travel grants in the past. I got one travel grant last year. I got one in 2024. But this was the only one I pursued because it was directly in line with my field. The one I got last year was for a conference in Taiwan. And Taiwan is not really a part of Asia that I want to visit for the first time, right? So that's why I turned it down. The same one for 2024, it was a meeting, a leadership meeting in Tunisia, and it was partial travel grant. So I turned it down. So this year I then decided to push for RAS travel grants, and by God's grace, I was able to get one. Like I said, I didn't get idea grant. I remember that day idea, all of us received rejection. Everybody in my school that applied for that grant, anybody I may say, they would just say everything is rejection. They were able to select, I don't know how the idea committee did it. They selected 4 students from FUTSMINA and 1 from FUNAB. I think those are the only Nigerian students that were selected for idea this year. I may not have counted correctly, but these are the ones I'm aware of, right? So this is the travel grant that a lot of people are always interested in, that IDEA, because the opportunity is always there to go for the conference. But most travel grants in ITBU have to do with you attending the conference. This was actually the first travel grant I saw that had to do with you're not just attending the event, you're speaking at the event. I mean, I was given 10 minutes to come and speak about democratization of soft robotics in the field of or in underrepresented fields rather. So it was an amazing opportunity. I mean, standing in front of professors and talking to them about access, improving access. I still have some of their contacts. I'll still reach out to later on in the year when I'm implementing the framework I presented it. So it's not about presenting something. I had to research how do I frame this work we are doing? How do I bring about a framework based on the outreach we do here, so we can be able to implement it? And at the end of the day, I was able to get something to present, and hopefully before the year runs out, we are looking at fundings. I've applied for 2 grants to see if I can implement the framework I presented there, because most research work is always validated in the environment, like in real time, like this project here. So you don't just talk about a research work without implementing it real time. So like that, these are just the benefits of being in RAS. I mean, every year I always look forward to renew my membership. I just joined ITP in 2024, but I'm always enthusiastic about the opportunities in RAS. We have different opportunities in RAS that open up, let me say, bi-monthly. Yeah, at least once in 2 months. There was one that closed, I think that was April, the technical education program, whereby RAS funds student branch chapters or student bodies that want to host a seasonal school. It's called a summer school program, whereby robotics, you can host like a month-long robotics training and you get funding like up to $10,000 just to host an event. But before you do that, you must get at least 2 technical committees to approve your proposal. So that's the the tough part of that grant. We also have I think this one on Sparks. Where is it? This Sparks one is a bit complicated. When I mean it's complicated, is you have to find a mentor to approve your proposal before you apply. I think it's what's the full meaning. Sparks is support program to foster academic relationships and exchange. So it's designed to bridge the gap between aspiring researchers from developing countries to be able to build a project or something. So perhaps later on you guys can research on this. I've not had time to apply for. It's not every proposal I can apply for now. I just focus on those ones that are directly in line with what I'm doing for the meantime, and perhaps one day I'll eventually need this, right? So I don't know if you guys are aware, but ICRA is currently going on in Vienna, Austria, and we got 4 students that were supposed to go for the conference, plus the guy from my school that won prize. But unfortunately, let's say Nigeria happened to them, in that the Austrian embassy unfortunately didn't give them visa, all of them. It was crazy. Seriously, I mean, I was lucky with Japan embassy. I mean, this was my first time leaving the country. They asked me for a lot of documents, but at the end of the day, the embassy is strict. But once you're able to meet up to their criteria and they are going to present something, I think what helped me was I was going to present something. So like that's how they gave me a temporary visa. But I don't know. They say the Australian embassy, the officers they are sadists in that they did not even at least consider one of them. It was really crazy getting an opportunity like this, but you'll be turned down because of, you know, the the situation in the country, how they don't trust Nigerians anymore, unfortunately. So we also have students that got travel grant last year, this idea to Seoul, South Korea. That's the Humanoids Conference to South Korea. But there was a particular document that I think the one of the awardees told me that they needed it to be notarized from South Korea directly, but the conference organizers wouldn't release the document. According to them, is in breach to their contract. It goes against their policies. In fact, IEEE has a lot of policies that they always meet up to. So, like, unfortunately, they couldn't also go for the conference, right? But we had someone that went to China last year. I think Tosin went to China. He also went to US before this ban happened to Nigeria. So, despite the discouragements, I mean, we have students that win travel grants and they don't go for conference, but it still doesn't stop you from applying. That's one thing about me. I've applied for IDEA twice. I applied for it in 2024. I did not get it. I applied for it in 2025. I did not get it. The one I now got was the one I didn't even put interest in. I see the application. Very, very simple. They just told us, I've forgotten what they asked in the application. Okay, they say drop CV, drop a 1 minute video, and then say one or two things about your research work. I mean, I've done research, but it's mostly in embedded systems. So I just drew from the outreach program I did last year, and okay, to them, okay, this is what we want to do, this is what we are planning on doing this year to improve, you know, access, right? So like it wasn't, I applied for this and did not put mind in it because I was like, let me just apply. You don't even know the one that work. So it's the one that I not put mind in that I eventually got. So IEEE has different opportunities, and I've always been enthusiastic about RAS because it's directly connected to the field where I am. So I am involved in other societies, but my major involvement is in RAS because I've been here since 2024, right? So ICRA is going on right now in Austria, and this is our standards group chat. Like I said, I'm a volunteer for the standards group. So kind of we had a meeting. Today is Thursday. We had a standards working meeting yesterday. So I attended ICRA virtually. I can actually post about it. I attended a section in ICRA virtually, right? But that's not really a big deal anyway. So basically, the conference is, like I say, is the largest robotics conference in the world. You can browse about it. It's the largest, I think, followed by IROS that is happening in US by October, right? So like there are a lot of benefits of joining RAS. I mean, these are the idea awardees. There are supposed to be 8 here. This is the idea what they're supposed to be. This lady is looking like an Indian lady, and then these guys. But unfortunately, 4 Nigerians that were supposed to be here, they didn't get their visa. So it's really painful. I mean, Nigerians, we have to still keep pushing and don't be discouraged by all this. So I was able to follow ICRA virtually, in that I have been able to see amazing pictures from the conference, and it's just wonderful being in a global committee like this, because you get to interact with different people, get to volunteer. I know one of the volunteers here is, I'm not the only Nigerian here. There's a guy from Uniport. There's also a lady, I think Glory Bangai. I think she's in Futmina, right? So you go on their website. I think the opportunity is always open to volunteer, but they do it in cycles. Like something I applied for in 2024, they just onboarded me like April, right? So like there are a lot of volunteers here that are not just in Nigeria alone, from different countries. You get to interact with different people. You get to volunteer in ICRA. There's the guy from Uniport. He helped to design a slide for the tech talk that happened in ICRA yesterday. He was able to help I think the chair of the event. He was out of town, so they are just looking for volunteers. Anyone willing to design slides for the conference? He just volunteered himself and he was able to do. So in the future, they can easily reach out to us here for opportunities, and hopefully travel grants can open up for us too. So these are just the amazing opportunities in IEEE RAS. So please join. we have, a lot of opportunities are always coming up to get students engaged in IEEE and RAS as a whole, or rather RAS and then IEEE as a whole, right? So I think that's just going to be the end of my talk, right? So if you have any questions, you can definitely drop them. Thank you.
That this was a very, very wonderful session. I hope we all learned a lot. One thing I learned is that it pays to apply. So and do your research, go through the website, every single thing. So now we're open for questions. Please, if you have questions, okay, Ebube.
Yes. Chizaram, thank you for that wonderful talk. Um, I'm very grateful for that. So, well, I wanted to ask, um, for the role that you are in now, I think SSC representative, right, for Nigeria. So, was that also open, or how did you get that? And then I just wanted to comment on, I think what she was talking of, visa denials for a lot of people is happening a lot nowadays. So it's not something to discourage you. You have to keep applying, like you said. So just keep applying and applying and applying, and you get something one day. So yes, so that's my question. Is, if you got that.
Okay, sorry, I didn't get the second question, but I think your first question is asking about how I got the SSR role, right? Please confirm. Okay. So okay, yeah, it was in 2024 actually. I saw it on the website. Like I said, I always ransack different websites. I just joined IEEE in 2024. So I needed to know more about the opportunities in the community. So I saw the opportunity open in RAS website 2024 to become SSR, and but we had to reach out to the section chair to endorse our proposal, and then the last tier Nigerian section, which is Dr. Otto. So I reached out to them via email and they were able to endorse my application. And it turns out no one else applied for it. So it wasn't a contest. So that's how I got the role in 2024. So basically the role is just to improve accessibility. That's for us. So the I represent RAS for my country in the Slack group chat. So when we bring about initiatives for opportunities in RAS, so like how do you get your section interested in opportunities like this? How do you push for students to be participating, and how do you also push for RAS to be formed in other student branches? So that's one of our roles, just raising awareness of RAS events, initiatives and opportunities within our section. Spice, I'm definitely sure I'm the one that brought Spice to the section group in 2020. I think it's 2025 or 2024. No, it's December 2024. Spice has been open since December, since since 2020, but nobody knew about the opportunity till I brought it to I think it's a section SAC group chat in 2024. That's how Tosin was the first Spice awardee. He won the grant to Accra last year. So that's the thing. So that's our responsibility. Just improve, or rather raise awareness of IEEE RAS events, assist in organizing workshops and activities. And then what I'm doing now is raising awareness of RAS. So that's one of my many roles in RAS. And yeah, that's just basically that.
Um, thank you so much for that. Please, if you have questions, please you can raise up your digital hand and then we call on you. If it's questions from the first session, second session, and third session, please raise up if you have any, or you can just type it in the chat. Any questions? If people are not asking questions, I was understood everything, right? Um. Okay, I think there are no questions. So we are coming to the end. Or Usman, please, do you have anything to say?
Um, good evening once again. That's actually very interesting. I think she did a lot. Our invited guest, I mean, she really did a lot and learned a lot, and it's going to help us to see how we are going to stay up once it is fully approved by the approvers here in ATBU. Like I've said, I won't convince everybody to join robotics, but if you choose robotics, I will convince you and persuade you to join IEEE RAS, which is very, very important. If you are planning to do masters abroad, at least all this kind of conference attendance, publications, awards will make it easier for you to get scholarship. That one is beyond any doubt. So, um, I mean, you have seen how she discussed about it from her journey, right from her journey from the university to where she is now. That means it requires like it's not going to be success all the time. Sometimes, like my boss said that when you fail, you have to lie down and enjoy the failure. But rise up fast. That means when you feel that hot of failing, enjoy the failure a little bit and then rise up fast so that that failure will not become something that will drag you from trying again. So that is to say that we have a lot of things to do. If you're really going to do robotics, you have to touch your bed that it's going to be hard, it's going to be easy. And we really need accessibility to all these things, all these grants, trainings, a lot of things that we don't have. He have said what he have seen there. It seems like it was science fiction. That is to say that we still have a lot to do. Because doing robotics is quite, like I've said, is quite different with embedded systems. They are related, but they're different. Now, until you can get all this access, you can go there, witness those things. You cannot even understand the differences if you are not even taught. So, thank you very much, our invited guest and our chair here at ATBU. Yeah, everywhere. Thank you. We really appreciate it. And by God grace, when we have another session or another webinar soon within the year, by God grace, after we are being fully approved, we would like to invite you for another webinar. Thank you very much, the moderator, the deputy chair, everybody, the audience, or should I say, the audience are the spectators. Some listen more than they see, like they watch, some watch more than they listen. Thank you very much. Thank you very much. Thank you very much. We really appreciate it. And as we start the journey into the unknown, because that's the words that's the taking we use at Aurora into the unknown. I wish everybody will be committed. Don't allow ATBU alone to compress your dream or the commitment you give to robotics. I'm not saying you should leave your studies and focus on it, but at least allocate a time. If you can follow the procedure they've stated in Atomic Book, allocate a time to be developing habits of going into these robotics communities, learning what is going on, and then implementing it. Is very, very important. There's a philosophy we have at Aurora Robotics that collaboration over competition. You're not competing with anybody based on skills. Everybody is unique in his or her own way. So you just have to collaborate. When somebody is doing hardware, you do software, and you try to bind the knowledge together to do something very incredible. So thank you very much. Thank you very much. Thank you very much. We really appreciate for although we haven't fully set up the executive committee that will truly run the RAS, but we soon do it so that if you have any issue, anything, you wanted to us to help you address, we can do our best to do it. Thank you very much. Thank you very much. Really appreciate. Thank you, everyone.
Thank you. Um, does anyone have any other thing to say before we round off? Nobody? Okay. With this, we have come to the end of this